Okay, so the back page of the Pythagorean Theorem application, it says a guide wire, which is usually called a guide wire, is attached to an upright pole 6 meters above the ground. So again, I'm going to use the blue here to draw the pictures. So I've got this pole, and I've got this wire attached to it right here. Okay? It's 6 meters above the ground. So this is 6 meters. The wire is attached to the pole 6 meters. And a guide wire or a guy wire is kind of it's a support wire is what it is. You'll see it a lot with power line poles and things like that. When you go camping and you throw a tent up, you have ropes that are kind of like the guy wires for your tent that hold your tent up. The wire is anchored to the ground 4 meters from the base. So it's anchored over here 4 meters this way. So it wants to know how long is the wire. Well, an upright pole is going to form a 90-degree angle. So we're going to use Pythagorean Theorem here, and we're going to, I don't notice a Pythagorean triple here, so we'll just use it. And since I've got the 2 legs, I'm going to add. So 4 squared plus 6 squared equals the length of my wire squared. I'm just going to call it W. So, 16 plus 36 equals W squared. 16 plus 36 is 52 equals W squared. And then I'm going to square root both sides. Now, 52 is not a perfect square, so I want to see if I can actually simplify that radical some way. So I'm going to take the 52 over here and I'm going to factor it. 52 is 2 times 26. The 2 is prime. And 26 is 2 times 13. 13 and 2 are prime. So basically the square root of 52 I can rewrite as 2 times 2 times 13. And what are we looking for again when we simplify radicals? Perfect squares or pairs. I've got a pair of 2's. For every pair, 1 comes out. So the 2 comes out, so I'm left with 2 square root of 13, and that's meters. And that is the length of my wire. If you actually want to get the decimal length of the wire, you would hit 2 second square root 13. So the wire would actually be about 7.2 meters long. So either one, okay? So now let's look at number 7. Number 7 says the size of a television is given by the diagonal measure of the screen. So when you buy a TV, the TVs are rectangles. And when they tell you the size of the TV you're going to get, it's basically the length the diagonal is. So a 37.2 inch TV, and that's inches, has a width of 30 inches. How tall is the television? Okay, well, let me rewrite this a little bit. So that'll be 30 inches. So the question is, how tall is it? Well, this is Pythagorean Theorem territory again. And because I have the hypotenuse, which is the diagonal, and one of the sides, I'm going to subtract. So 37.2 squared minus 30 squared is going to equal the height of my television. Okay, so I'm going to turn on my calculator and do 37.2 squared, which is 1383.4 minus 900 equals the height squared. Okay, and so I get 483.84 equals height squared, but I want height, so I'm going to square root it. And this is not something that you're going to be able to simplify because it's ugly. So you get 21.996, which rounds to 22.0. So 22.0 inches. That is the height of your TV. Okay, so let's look at number 8. On number 8, you've got a ship leaves port and sails 14 kilometers west. So west is this way, so I'm going to draw my little ship here. We're going to go 14 kilometers this way, then 48 kilometers north. Ignore the fact that 14 and 48 look wrong. 48 kilometers north. So west and north form a right angle. The question is, how far is the ship from port? So how far is the ship away from where it started, if it went 14 kilometers west and 48 north. Good old Pythagorean theorem again. So 14 squared, sometimes I put parentheses, plus 48 squared equals c squared. You can do c, d, whatever you want to do. 14 squared, I believe, is 196, plus 48 squared, which is 2304, 2304, equals c squared. Together they combine to give you 2500, and I'm going to square root both sides. So if I take the square root of 2500, I get 50. So the ship is actually 50 kilometers from where it started, if it goes 14 west and 48 north. Okay, let's look at number 9. Number 9 says each side of a square checkerboard. So here we go, we got square. Square implying 4 right angles and 4 congruent sides. Each side of a square checkerboard measures 40 centimeters. So we've got 40 centimeters all the way around. What's the length of the diagonal of the board? Okay, now one thing about a square. The diagonal of a square cuts it in half and bisects the angles. So that creates 45, 45, 90 triangle for you. So that means that this is 45 and that's 45. So if I were to just pull the one triangle out, I know it's going to be a 40 and a 40, and then this is 45 and that's 45. So the question, what's the hypotenuse? There's a shortcut. In a 45, 45, 90, remember, the ratio of the sides is 1 to 1 to square root of 2. So whatever the side lengths are, you multiply them by square root of 2 to get the hypotenuse. So since this is 40 centimeters, my hypotenuse is going to be 40 square root of 2 centimeters. I don't even have to do the Pythagorean theorem. If you want to, you can do the Pythagorean theorem and do 40 squared plus 40 squared equals x squared, and you can solve it that way, but you'll get the same thing. So use that 45, 45, 90. Okay, number 10. A 9.8 meter inclined ramp rises over a horizontal distance of 9 meters. So it's an inclined ramp. So here's your ramp, and it's inclined at 9.8 meters. The horizontal distance is 9 meters. So how tall is it? Well, Pythagorean theorem. And again, I have the hypotenuse and a leg, so I'm going to subtract. So 9.8 squared minus 9 squared is going to give you the height squared. So I've got 9.8 squared, and that is 96.04 minus 81 equals h squared, and that's going to come out to 15.04 equals h squared. I'm going to square root both sides, so I'm going to take the square root of that answer, and I'm going to get 3.878, and I only want one decimal place, so the height is 3.9 meters. Again, all done Pythagorean theorem. You should be Pythagorean experts by now. Okay, number 11. We did this one in class, but what we have is we have a television that has a ratio. It's a rectangle because televisions are rectangles. It has a width to height ratio of 9 to 5. So that this is 9 and this is 5. If I want a 36-inch TV, what is the surface area, which it should say area, what's the area of the screen, and what's the actual height and width? Well, we have to establish a scale factor here. If we're going to increase, remember we talked about photographs, we've got to establish a scale factor. So if I have a 5 by 9 as my base screen, my smallest possible screen, what would my diagonal be? Well, 5 squared, I'll just do it in blue, 5 squared plus 9 squared equals d squared. 45 plus 81 equals d squared. So you got 126 equals d squared. And we're going to square root both sides. And so that's going to come out to about since we can't really factor 126, oops, you get 11.2. So 11.2 is what the screen would be for the little one. Now, if I were to draw a big one, I'm going to come over here and I want a big TV. And in this big TV, I want my diagonal to be 36 inches. So the question is going to be, what's the height and what's the width? Well, if I'm going to jump from 11.2, which is what this one is, to 36, I have to establish my scale factor. Now remember the scale factor, and I'll come down here. Remember the scale factor is new divided by old. So what's the new one? 36. What's the old one? 11.2. If I do 36 divided by 11.2, I get a scale factor, which we call K, of 3.2. That means that this TV is 3.2 times bigger than this one. So what does that mean about the height and the width? Well, I'm going to take that 3.2, that scale factor, and I'm going to multiply it by my original height and width. So for my width, I want to do 9 times 3.2. If I do 9 times 3.2, that means my TV would have to be 28.8 wide. And if I take the original height, I'm going to do 5 times 3.2. That means it has to be 16. So there's my height and width. You have to establish the scale factor first. Okay, last one. Woohoo! The window of a burning building is 24 meters above the ground. Let's hope we never catch on fire. So you've got your building here. Got your windows. The window is 24 meters above the ground. The base of the ladder is 10 meters from the building. So that's where the ladder is going to be. And then you're going to have your ladder up here. Question is going to be, how long does the ladder have to be? Well, it's Pythagorean theorem. Now you can recognize this as a Pythagorean triple. I do. But if you don't, let's do Pythagorean theorem. You have 10 squared plus 24 squared equals the ladder squared. I'm going to put L squared for ladder. So 100, so 100, and I believe it's 676, no, 576, plus 576 equals L squared. So 676 equals L squared. I'm going to square root both sides. And the second square root, 676 is 26. So it has to be 26 meters. So the ladder would have to be 26 meters to reach the window. And that's your Pythagorean theorem.